great job on that. Should we keep cranking it?
Yeah.
Number 2, it says examine the velocity versus time graph to the right, describe the motion. Is this a position versus time or velocity versus time graph?
The velocity versus time.
Excellent. Look at the y-intercept of our velocity versus time graph. Do we start at rest or with a big positive velocity or a big negative velocity?
A positive.
A big positive velocity. And what's the velocity at 3 seconds?
0.
0, right? And then what's the velocity at the end? Some big negative velocity, right? So if in the first part of this, is it moving in a positive or negative direction on the first half?
Positive.
Positive, because it's above the time axis. And Ellie, what direction is it moving in the second half?
Negative.
It's moving in a negative direction because we know that it's below the time axis. So those are negative velocities. So what kind of description of motion do we have here?
The object starts at some positive position.
Do we see a starting position from our velocity versus time graph? No, we see a starting
Velocity.
velocity. So we know it's going fast in a positive direction at the beginning. So let's just start with that. The object is moving fast in a positive direction. Oh, that's supposed to say, you know. And ladies, as time goes on, we have a smaller positive velocity and a smaller positive velocity and a smaller positive velocity and eventually a velocity of 0. So what's the object doing?
Decreasing.
It's decreasing. What's decreasing?
The velocity.
The velocity is decreasing, so is it speeding up or slowing down?
Slowing.
And it slows down until it
Reaches 0.
a velocity of 0. So what did it do if its velocity is 0?
It
Stops
stops.
moving.
It stopped. Wait a second. I feel like we saw that one of the cars on the track did this. When did the car move fast in a positive direction and slow down as it went along the track until it came to a stop and then sped up in a negative direction? When did the car do that?
When it was
When you
going
push,
forwards
when
and
you push
backwards.
When we gave the car a push and it went up the track, and when it went up the track,
And
it
then it
slowed
stopped.
to a stop, and then what did it do after that?
We move back down the ramp.
And while it moved down the ramp, it
Sped up.
sped up. Is that what we're dealing with here?
Yes.
So we can use that in our written description. Slows down to a stop, then speeds up in a negative direction. Draw blue velocity vectors at time 0, nope, at 1 second to 6 seconds. Blue velocity vectors, you guys ready? There's already one at 0. There's one at 1 second, at 2 seconds. We don't put one at 3 because there's no velocity vectors. Uh-oh, what do I do at 4 seconds?
Upside down.
So my velocity vector, Ellie is proposing that we have the arrow point downward because that's pointing in a direction, right? I think that's a good choice. And then at 6 seconds, we go to there. Next up, we have to add the red acceleration vectors. Remember, acceleration is describing the way velocity changes. So, is the velocity from 0 to 1 second, is it having a positive or negative change in velocity?
Negative.
Negative change in velocity. So it says, draw red acceleration vectors. Number 1 has been done for us. And I think the red acceleration vector was here. And that puts us at the corresponding velocity. And then, and I'm going to use an infinite cloner button after I do this next one so they're all the same size. This is the best. Cheating's the best. I just put that on tape and put it out on the internet. Cheating's the best. Are we good? Don't cheat. Cheating's wrong. And boom.
We have a question. Why is the red on the bottom of the negative
if it already, undo. If the velocity was already that, and we want the velocity to change by this much, look what happens when we do the blue. I'm looking over here at 0 seconds right now, right at this time here. If you do the blue minus the red, it takes us to the next blue velocity vector. If we do blue minus the red, it takes us to the next height of the next velocity vector. Blue minus the red takes us to a velocity of 0. Now, the red acceleration vectors are still negative, right? So it takes us to the height of the next blue velocity vector. So this one takes us to here. So you're now, because it's negative, the velocity is negative and the acceleration is negative, it's now speeding up. So when we saw this in the lab, right? When the velocity vectors or acceleration vectors are in the same direction, it speeds up. But when velocity is one direction and the acceleration is the other direction, it slows down. Thanks for asking that. Alright, so next up we need to do a motion map for this. So if we're gonna go up and down the track, do you guys want to start at 0?
Yeah.
Great. And it's gonna speed, is it gonna speed up or slow down on phase 1?
It slows down.
Slows down. So we're gonna have to start with our dots really far apart from each other. I'm gonna go ahead and do 1, 2, 3, 4 hash marks, and then 1, 2, 3 hash marks, and 1, 2 hash marks, and then 1. Let's go ahead and draw the velocity vectors as the car would go up the track first. So a smaller and smaller and smaller positive velocity. And then how big of a velocity vector should we put on our last dot?
None.
Why? Because when the car reached the highest point, the car did what?
Made it rest.
It came to a stop, right? Right, it came to a stop. So no velocity vector on the top one. But then what did the car do? The car moved back down the track. And so as the car moved back down the track, the distance between the dots would get bigger and bigger. And what direction should our acceleration vectors be? Look at phase 1. What kind of acceleration do we have for phase 1?
A decreasing.
Negative.
Allie is noticing it's a negative slope for phase 1, and Taylor noticed we have what slope for phase 2?
Negative.
Still negative. It's a constant negative slope, so that means we have to have a constant negative acceleration. So all of our acceleration vectors will all be the same length. And I'm going to go ahead and choose that infinite cloner button again. Let's see, we'll put it there. Oh, I missed the position dot. I need to do a better job. Uh-oh, I have a question. What about when the car was at the top of the ramp?
Yeah.
Does it get a velocity vector? Taylor already told us no because it wasn't moving, and that's true. But should it get an acceleration vector?
Oh, yeah, that's
Yeah.
it.
Yes, an acceleration vector. Why? It's not speeding up or slowing down there. It's
Because the velocity is still changing.
But it's remained at rest.
what's changing. What's changing? We said velocity. Well, it actually is slowing down prior to that, and it's speeding up after that point. But what's the car doing right in that moment?
Going backwards. It's changing. It's changing direction.
It's changing directions. Brilliant, Taylor. Ah, I didn't put I need to do a better job putting my acceleration vectors on my position dots. Are we good to go on that?
Yeah.
Oh, yeah, wait, I'm over here.
So, do you guys have any questions before we get rolling?
I'm over here.
Yeah. So, how about maybe we won't do this whole one, but it looks like, just in general, if we take a look at the graph, what direction is this thing going at the beginning? Is it moving in a positive or negative direction?
Positive.
Negative.
Oh,
Negative because the line is below the time axis. And as time goes on, we have smaller and smaller negative velocities. What's our final velocity?
Zero.
0, which means the object came to a
Stop.
stop. So it looks like we're going fast in a negative direction and we slow to a stop. And I'm sure the directions along here are going to want us to draw out our velocity vectors again and show how, with acceleration vectors, how the velocity is changing each time, right? And go through that same process. In this one, since we're going in a negative direction really fast at the beginning, should we start our position dots closer to 0 or far away from 0 if they want us to move in a negative direction?
Farther away.
We should probably start farther away, and if it's moving fast at the beginning, is the distance between our dots going to start out small or big if it's going fast at the beginning?
It's gonna be big.
Big. 1, 2, 3, I'll put 4 dots. I think that's enough guidance for this one, and I think the kids can do it on their own from here. Thanks for your help, ladies.